Hello, this is Gregory Maxwell, and this lesson is on solving inequalities, in particular compound inequalities, polynomial inequalities, and rational inequalities. I'd like to point out here that this is not a basic review of inequalities. You will need to have a basic understanding of how inequalities work and the basic operations of solving linear inequalities in one variable. This lesson goes more deeply into solving more complicated inequalities. Even so, let's go through a few basic facts about inequalities. An inequality, generally, this is from the middle school concept, eats the greater number. The greater number is where the open section of the inequality is. So in my example here, x greater than 9 means x is the symbol here opens up to the x. That means x is the greater of the two numbers. And in this case, 5 is less than x. In this case, x is also the greater of the two numbers, and 5 is the lesser. In this case, 12 is greater than x, which means x is less than 12. And again, x is at the smaller section, so it's the lesser of the two numbers. Now, on the number line, greater simply means to the right of, or if it's a vertical number line like the y-axis, greater means above. So x is greater than -3 on this number line means x is to the right of -3. And of course, that means less means to the left of or below. So on a horizontal number line like the x-axis, x less than or equal to 13 means x is either to the left of 13 or at 13. All right. So, and if it's a vertical number line, then that would mean x is above 13 or at 13. Another couple of things I need to point out here. Bigger or larger are not the same as greater. Larger just means further away from zero, bigger in quantity. Greater means is a position to the left or, to the right. Greater means to the right or above. Larger means further away or more in quantity. So -13 is less than 5, but -13 is a larger number than 5 because if you take the absolute value of -13, you get a larger number than 5. Think of it this way. If you went to buy an item that costs $13 and you only have $5, you would not be able to afford it because the amount it costs, the deficit it will put in your wallet, that -13, is greater than the amount that you have currently, unless you want to go into credit, in which case you'll have a -8 amount of dollars now. Similarly, smaller does not mean less. Smaller means closer to zero or in lower amounts. Less means to the left or below. Smaller means the size is more diminutive. The absolute value is smaller. So a smaller number could still be greater because it just is on the right side of the larger number. For example, -13 is less than 5. 5 is a smaller number than -13 because if you take the absolute value, the absolute value of -13 is a bigger number than 5, but 5 is to the right of -13, so 5 is greater. So that takes us to the next step. When we're reading graphs for inequalities, we typically read from left to right, because that's how we read in English. So when we're reading this graph here, we're saying we're going from negative infinity to up to -3. Now, negative infinity is like, and positive infinity are interesting. It's kind of like the horizon. That's how the infinity works. And infinity is written like an 8 on its side. Negative infinity means you're going all the way to the left. Positive infinity means you're moving all the way to the right. And infinity is like the horizon. You can see it, but you can never get there. So with infinity, it's not an actual number. It's more like an unachievable destination. And so negative infinity is to the left, positive infinity is to the right on the horizontal number line, but on the vertical number line, negative infinity is below and the positive infinity is above. Now, in interval notation, and this is a very important notation that I will do a quick summary of in a few slides. In interval notation, less than and greater than are represented by parentheses, kind of like what you used to do with the hole in the graph. So if you see a parenthesis, it means that that number is a boundary, but it's not included in the set of values that are considered. So when we say x is greater than negative 10, that means we are looking at x values to the right of negative 10, but not including negative 10. So we'll shade all the numbers to the right of negative 10, but we'll put a parenthesis at negative 10, opening in the direction that we shade because negative 10 is not included. If we want to include the number, we use brackets instead. So there's a distinction between parentheses and brackets in mathematics. If you want to include the number, that you use a bracket. And in this case, for example, x is less than or equal to 30 means x is either to the left of 30 or equal to 30. It's at 30. So we shade everything to the left of 30 and we put a bracket that opens in the direction that we shade. Now that takes us to interval notation. Interval notation matches the graph. So where the graph starts, the interval notation starts. Where the graph ends, the interval notation ends. If the graph doesn't have a beginning, then we say we're starting at negative infinity. And negative infinity, since we never get there, always has parentheses. If the graph has no end, then we say we're going toward positive infinity. And as with negative infinity, positive infinity has no end. You can never get there, so it's not an end value. It's only a destination, so it always uses parentheses. Infinity always uses parentheses. If you want to represent an interval using a graph using interval notation, it's best to graph the graph on a number line and then copy, so to speak, the interval. So let's talk a little bit about regions where graphs overlap and where we use the word or and and. And means both statements are true at the same time. So for example, if we say x is less than or equal to negative 2 and x is also greater than negative 4, we're saying we're looking for all numbers that satisfy both conditions. So what we can do is graph each part. If I graph x is less than or equal to negative 2, I'll just put a bracket at negative 2 that moves to the left and shade that direction. So basically, this region here is from negative infinity up to negative 2 with a bracket. If I'm graphing the other region, x is greater than negative 4, I'm shading to the right of negative 4, but I'm using parentheses because there is no bar there. It's a strict inequality or an open inequality. So this interval would be a parenthesis opening at negative 4, then a comma, and then the last value would be positive infinity. And the interval notation does that. It tells you the first value, a comma, and the last value. So in this case now, the two regions begin to overlap at negative 4, the parenthesis term, so just after negative 4, and end up and stop overlapping at negative 2. So we start with parentheses negative 4 and stop at bracket to negative 2. So the interval notation is parentheses negative 4, comma, negative 2, bracket. That's for overlap. Now, when we talk about whether we can choose either region, we call that OR, and that represents a union. That means when we say x is less than negative 5 or x is greater than or equal to 1, we're saying if x is in either region, that satisfies what we're looking for. So we shade all the areas that meet either condition. In this case, we shade to the left of negative 5 with a parenthesis and to the right of 1 with a bracket because it's included. And then we say, well, those are my possible solutions. So either the solution falls into this category, negative infinity to negative 5, or it falls into this category, bracket negative 1. And I'm sorry, I have it wrong here. So let's use a negative 1 right here because I made a slight error here. So negative 1 up to positive infinity. Either of those regions would be sufficient for a solution. And so when we put them both together, we indicate that we're using OR with a little union symbol from set notation. All right, from set theory, I should say. Okay, so now that we have that, let's take a quick look at one more thing. And this is how do we solve basic compound inequality, where three parts inequality. Now, in this one, this is one of those concepts from intermediate algebra that I recommend that you review. And the shorthand for this is if the variable is totally in the in between the two inequalities, and the inequality should open from least to greatest, and it should always going to the right. So the values to the right should be greater than the values to the left. What we do, we isolate the variable between them. If there's more than one variable, then you have to split the inequality, and that is for a different concept that is covered in intermediate algebra. What we do is we subtract 28 from all parts, and when we do that, the result is negative 7 minus 28. It's negative 35. The negative 28 cancels here, and the 13 minus 28 is negative 15. Now, to get the x by itself in between those two, I divide by a negative 5. When I divide by a negative 5, the inequality reverses because now all positives become negatives and all negatives become positives. So it creates a mirror type of effect. And so now the inequalities get reversed. But we always read inequalities from left to right, and this is being read from right to left. So what we do is we reverse them, saying, oh, we're supposed to be saying 3 is less than or equal to x is less than 7. So let's write it that way. And then we can graph them on the number line, starting at negative 3 and ending at 7. And then we can write our solution using interval notation. So our solution here would be bracket 3 comma 7 parentheses. Now, let's take a quick look at a quick little table here. This table summarizes interval notation with set notation. If you say x is greater than a number, then interval notation says you start at that number with a parenthesis and go to the right. And so we'll say parentheses a comma 8. So if x is comma infinity. So if x is greater than 8, that can be written as parentheses 8 comma infinity. And then of course, if it's between these two numbers, we just put parentheses at both ends. Parentheses negative 13 comma 5. The starting number comma ending number. And if you have no beginning, then you're starting at negative infinity. So if you look at the number line here, you're going from negative infinity all the way to the number, which in this case is negative 12. The same thing works if it's an inequality that has a bracket. So we start at a and stop at and go on forever. So we start at negative 8 in this example and go on to infinity. In this case, I start at 2 and end at 25, but I don't include 2 because there's no bar and there's a bar 25. So we say parentheses 2 bracket comma bracket 25, 25 comma bracket. Then it works the other way as well. We start at negative 4, end at 5. If you notice, we go from lesser number to greater number all the time. And that's how you write the interval. In this case, x is less than or equal to 7. That means we're shading to the left of 7, but we're putting a bracket there. So the number on the left is negative infinity, and the number on the right is 7 with a bracket. And in this case, it's pretty easy. It starts at a number and ends at a number. Negative 9, a bracket negative 9, and a bracket negative 1. And when you're using all real numbers, then the result is just negative infinity to infinity. All right, so before we go on to solving polynomial inequalities, what we're going to do is we're going to do a little solving of a few linear inequalities, just to remind us of how to do a few of these. So in this case, we solve linear inequalities like we solve linear equations with a couple of adjustments. We distribute the negative 4 here. So we have 8 minus 8 plus 4x is less than or equal to negative 2x. And of course, 8 minus 8 is 0. So we end up with 4x is less than or equal to negative 2x. And so to get the x's together, I add 2x to both sides. And when I add 2x to both sides, I get 6x is less than or equal to 0. At which point I divide both sides by 6, and so now x is less than or equal to 0. So if I were to draw the solution on a number line, so let me create a number line here. let's see what we will have, what it would look like. I would then mark the number, which is 0. And then this says the x values are to the left of 0. So I would shade to the left of 0. I'm shading above it so you can see the shaded region. And this says you include 0. So I use a bracket opening to the right, or to the direction that we shaded. Sorry, this is to the left. And then based on this graph, I can say, oh, so the solution using interval notation is we're starting at negative infinity, which always uses parentheses, and we're stopping at 0, which has a bracket. Let's try another one here. In this one, I can make my life simple by multiplying both sides by 2. And since I'm multiplying by a positive, I don't have to worry about reversing the inequalities. So I'm multiplying both sides by 2. Half times 2 just gives me 1, so that leaves me with x minus 4. And when I multiply both of these parts by 2, I get 2x plus 16. Now let's get our x's together. I will subtract 2x from both sides, and at the same time I'll add 4 to both sides. When I do that, I get x minus 2x is negative x, and then the 4's are gone, and the 2x's are gone from the right side, and 16 plus 4 is positive 20. I want x by itself, so I divide by negative 1, or whenever I divide by a negative, the inequality reverses, and that gives me x is less than negative 20. When I'm ready to graph that, the number I put on the number line is negative 20. And again, since x is less than negative 20, we're just going to shade to the left. And then I'll put a parenthesis because it's strictly less than, not including negative 20. So the solution then is negative infinity again up to negative 20, but this time with a parenthesis, because negative 20 is not one of the possible solutions. Now let's take a quick look at this compound inequality. The aim is to get the x by itself in the middle, so I need to get rid of the 3 first. So I subtract 3 from each part. I subtract 3 from each part, and that gives me negative 6 is less than or equal to negative 2x, which is less than or equal to positive 6. Then I'm going to divide each part by negative 2 so I can get the x by itself in the middle. Now, when I divide by a negative, the inequality gets reversed. So negative 2 divided by negative, negative 6 divided by negative 2 is positive 3, but that inequality now gets reversed. Negative 2 divided by negative 2, negative 2x divided by negative 2 is x, and 6 divided by negative 2 is now negative 3, but that inequality also gets reversed. So now we have this system here. But we're saying 3 is greater than or equal to x, which is greater than or equal to negative 3, which means the other way around means negative 3 is to the left of x, which is itself to the left of 3. And of course, we'll include them. And that now we can graph on our number line. It might be a little tricky to graph it here because the space is small. Negative 3 is on the left and positive 3 is on the right. That needs to happen. We shade between the two regions and we put a bracket at both parts because both of them had equals to. And then my solution using interval notation is simple. I start at negative 3 with a bracket and I end at 3 with a bracket, and that's the solution. Let's continue here. Down below we have another inequality to solve. So I'm going to subtract 1 from all parts, and that leaves us with 0, which is less than negative half x, which is less than positive 3. Then I multiply all parts by negative 2 so I can cancel the half. This is not x minus 2, it's multiplied by negative 2. When I do that, 0 times any number is 0, but since I'm multiplying by a negative, the inequality reverses. Negative half times negative 2 is positive 1, and then 3 times negative 2 is negative 6, and that inequality gets reversed. We move them the other way around, which should make sense here. Negative 6 is to the left of x, which itself is to the left of 0. So my solution, my number line is going to look something like this. My graph is going to go from -6 to 0. I would shade between them because that's where the x is. I'll put a parenthesis opening in the direction that I shade on both sides. And so my solution then is going to be open parentheses -6, comma, 0. And that's that. Now let's do one more example before we go on to the next concept. This example looks like it's a quadratic. Looks like it would be a little challenging. Well, since this is a 2x plus 1 squared, we have to write that twice. And at the same time, I'm just going to distribute this side as well. So the left side works out to be 4x squared plus 3x. And the right side, we have to FOIL. We have to do the distributive property because you cannot distribute an exponent over an addition or a subtraction. When we do that distribution, which I'll skip out one of those steps, I'm sure you can do that. You end up with, on the left side, we still have 4x squared plus 3x, but on the right side, we end up with 4x squared plus 4x plus 1. Now, I can get the x squares and the x's together, so what I'm going to do is I'm going to subtract 4x squared from both sides, and I'm going to subtract 4x from both sides. Let's leave the 1 there for now to see what happens. As you can see, it turns out that the x squared terms have to cancel. And that leaves us with negative x is less than or equal to 1. And now to get x by itself, I simply divide both sides by -1, and the inequality reverses, and I end up with x is greater than or equal to 1. And so this graph will basically have one number marked, one marker, which is 1. I'm sorry, which is -1. And we are shading to the right, and we're using a bracket. Now, what I neglected to do, which I strongly encourage that you do, is to check the solution. You check by plugging in a number in the region that is a solution to see if it makes a statement true, and then plug in a number that's not in the region to see if it makes a statement false. For example, with my situation here, if I plug in a number between -3 and 3, this statement should remain true. So let's see, let's say we plug in 0. If I plug in 0, which is the number between -3 and 3, I get -3 is less than or equal to 3, which is less than or equal to 9. That's a true statement. If I plug in a number to the right of 3, that statement will be false. I plug into a number to the right of 3, say 4, then I'll get 3 minus 8, which says -3 is less than or equal to -8. That is not true. -8 is not to the right of -3. -8 is to the left. Sorry, -5 is to the left of -3. So that would be false because it's not in the true region. So it's the same idea here. You should always check your solutions to make sure you have the correct answer. And I leave you to check the other solutions here. Now, let us continue with the next concept. The next concept is solving polynomial inequalities. Solving polynomial inequalities. And polynomial inequalities of y is 1. That is, the power of the polynomial, the degree of the polynomial is greater than that of a linear. It's 2 or greater. Linear functions are polynomials, but those are easy. The polynomials involve a little more work. I'm going to show you one method. There are more than one methods to do this, but I found this to be one of the simplest approaches. So that's what we're going to do now. So I have an example here. Solve this inequality. X squared is greater than 8x minus 7. So let's go through a few steps. Step number 1, we will first write this inequality in standard form. So I'll move the -8x to both sides and the negative 7 the 8x to both sides and the 7 to both sides. And that becomes x squared minus 8x plus 7 because I subtracted 8x and added 7 to both sides. Now, the next step is to take this inequality that is now equal to 0 and then, well, that has 0 on the other side, and we're going to solve the corresponding equation. So I'm going to substitute that inequality for an equal sign, and then I'm going to solve this equation. This is a quadratic equation. We can solve it by the quadratic formula or factoring. I choose to factor here, and so we get x minus 1 times x minus 7 equals 0. We set each factor equal to 0 and solve for x. Those numbers, I'm going to call them markers. So I'm going to put them on a number line. So that's my step 3. I'm going to take my solutions from step 2 and I'm going to put them on a number line in order from least to greatest, of course. So that my markers now are 1 and 7, and I'll put them on the number line. Now, let's proceed. Now that I have the markers, what I'm going to do now is I'm going to choose numbers around the markers, because what this is saying is that the inequality that we had is only equal to 0 at 1 and 7. That means to the left of 1, all the numbers give you the same sign. They're either all positive or all negative. Between the numbers we plug in will all be either positive or negative, and to the right, the numbers we plug in will either be all positive or negative. So what we're going to do, we're going to try a number to the left of 1. So for example, we can try 0, and we plug it into the standard form expression. 0 squared, which is x squared minus 8x plus 7. 0 squared minus 8 times 0 plus 7 gives you 7, which is positive, which means any number to the left of 1 will give you a positive result for that expression. Now, a number between 1 and 7 would be, for example, 2. So if I try the number 2 in this same equation, we'll get x squared minus 8x plus 7. Plug in 2, we get 2 squared minus 8 times 2 plus 7. That's 4 minus 16, which is negative 12, plus 7, which is negative 5. Negative 5 is a negative number. It's less than 0. So we put negative in that region where the negative 5 is from, saying any number that we use for x in that region will give us a negative result for that expression. And then we try a number to the right, which is, say, 9. I have 2 here, and I need to correct that. If I try 9, we get 9 squared minus 8 times 9 plus 7. That's 81 minus 72, which is 9 plus 7, which is 16. That's again a positive number. So there we have all our regions satisfied there. And let me just make a quick correction right here. Our correction is that we should have a 9, not a 2. So I'm going to just write the number 9 here. Now, let's move on. So once we have our markers and we have our regions that are marked, saying when we plug a number to the left of 1, we get positive. Between 1 and 7, we get negative. And after 7, we get positive. Now we're going to have to see which region satisfies the inequality. The inequality in standard form, that's this in the example, x squared minus 8x plus 7. Now, since x squared minus 8x plus 7 is greater than 0, that means the answers we want are the parts that are positive. And so we're going to shade all the parts that are to the left of 1 and those that are to the right of 7. To the left of 1 and to the right of 7. Since this is a strict inequality, we use parentheses for those boundaries. And so now we have a compound inequality, namely where the solutions come from regions to the left of negative 1 and to the right of 7. From the number line, we see we're going from negative infinity. Remember, negative infinity is on the left side and positive infinity is on the right side. We're going from negative infinity to 1 or from 7 to infinity. Any number from those regions would work. Let's do a quick check. If I plug in a number to the left of 1, say, well, we did check it already. That's how we got our solutions. So in the process of getting these answers using the marker actually gave us solutions. You can check other numbers if you so desire. Now, let's do a few examples of solving polynomial inequalities. So we have this. Now, this is already in standard form, and in fact, it's already factored. So what we're going to do is simply find the markers. So to find our markers, we're going to solve the corresponding equation. X minus 5 squared times x plus 2 is equal to 0. Since that's a factored polynomial, we just say that means x minus 5 squared is equal to 0, or x plus 2 is equal to 0. We do the square root of both sides for the left equation. We get x minus 5 equal to 0, which means x is equal to 5. And for the right equation, we just subtract 2 and we get x is equal to negative 2. So my markers are going to be negative 2 and 5. Now, we don't know what regions we're going to shade as yet. So we're going to put the markers in. We're going to put them in order. Negative 2 on the left, positive 2 on the right, positive 5 on the right. And then we're going to try numbers. So let's try. So we're going to try x equal to negative 3, which is a number to the left of negative 2. So we go negative 3 minus 5 squared times negative 3 plus 2. And that was going to give us negative 3 minus 5 is negative 8. And we square that, we get positive 24, positive 64. Negative 3 plus 2 is negative 1. Positive times negative is negative. So since we have a negative result, that means this region will give you negative answers. Negative answers. Then we try a number between them, between negative 2 and 5. The easiest number, of course, to try is 0. So I plug in 0 into the same expression on the left in standard form. 0 minus 5 squared times 0 plus 2. And then 0 minus 5 is negative 5. When you square it, you get positive 25. And 25 times 2 is 50, a positive number. And so we get a positive. You must be careful that you don't jump to the conclusion that if one region is negative, the next region is positive, and vice versa. You need to check all the time because sometimes both regions are the same. So now let's check our third region, our third example here. We check a number to the right of 5. For example, we can try 6. So I plug in 6. I get 6 minus 5 squared times 6 plus 2. So when I plug in 6 minus 5 is 1. 1 squared is positive. And when I plug in, when I square, when I multiply that by 8, I get positive 8. And there we have it. That region is also positive. So based on our little information here, since this is a less than, and these are all, this is a less than, we use parentheses and we only want the region to the left. So then my solution then is going to be the region to the left, and it uses parentheses. So I'm going to redraw my graph, which will only have the solution. The graph of my solution here, the graph of my solution will have one marker, namely negative 2, and I will be shading to the left of negative 2, and I'm using a parenthesis that opens in that region. So my interval notation for my solution is negative infinity up to negative 2 parentheses. And again, you can check with other numbers. So that's why, again, you have to be very careful about jumping to conclusions here. Make sure you check all your solutions. In this case, it's not in standard form, so we're going to try to get it to be the right form. So I'm going to subtract 9x squared from both sides, and now it's in standard form. And then I solve the corresponding equation, x squared minus 9x squared equal to 0. This can be solved by factoring. I have x squared times x minus 9, x cubed. So x squared minus x minus 9 is equal, times x minus 9 is equal to 0. And then we solve each part. That means x squared equal to 0 or x minus 9 is equal to 0. So that means our two markers here in this situation are 0 and 9. And then we draw our little number line, put two markers in this case, 0 and 9. And then we try numbers. I try a number to the left of 0, such as -1. And then I plug it into my inequality, my standard form inequality. -1 cubed is -1, minus 9 times -1 squared, which is just going to give us -10, which means we have a negative region here. And then I try a number such as x equal to a number between 0 and 9, which is 1 is a good number to try. 1 cubed minus 9 times 1 squared is going to still give us a -8 this time. So that now gives me a negative here. And then when I try x equals to, say, a number to the right of 9, say 10, we get 10 cubed, which is 100, minus 9. 10 cubed is 1,000 minus 9 times 10 squared, which would be 1,000 minus 900, which is 100. So that solution is a positive. And since this says greater than or equal to, we want the region that is positive, which is here. We're shading that region all the way to the right. And since that's a greater than or equal to, we're going to put brackets there. So my graph then will look like this. Again, only one marker for the graph in this situation. We're putting the number 9, and we're shading to the right, and we're using a bracket. And that's the graph. And the interval notation for the solution is we start at the number on the left, which is -9, and we go all the way to the right, which in this case is to positive infinity. And infinity only uses brackets. Now let's move on to the next example. Now we are going to be doing a few examples here because this involves quite a bit of thinking. In this case, we already have the inequality in standard form. So I'm going to solve the corresponding equation, x times 3 minus x times x minus 5 is equal to 0. And I neglected to say, but I strongly encourage you that you should be trying some of these questions before you watch the video solution and then checking if you have the correct answer. In this case, x is equal to 0, x is equal to 3, or x is equal to 5. So we have three markers here. We have 0, 3, and 5 in that order. 0, 3, and 5. So we're going to do some examples, choose some numbers from on the markers. We choose a number to the left of 0, such as -1. So we have -1 times 3 minus -1 times -1 minus 5. So 3 minus -1 is 4. So we have -1 times +4 is -4 times -6 is +24. So we have a positive answer right here. Then we try a number between 0 and 2, 0 and 3. And of course, the number we'll try is 1. Very easy number to try. 1 times 3 minus 1 times 1 minus 5 gives us 1 times 2 times -4, which is -8. So that's a negative number. So we're going to get a negative here. Then we go back and we try a number to the between 3 and 5, to the right of 3 and to the left of 5. So that, of course, is 4. Easiest choice here. So we have 4 multiplied by 3 minus 4 multiplied by 4 minus 5. And we see that gives you 4 times -1 times -1, which gives you +4. We got another positive answer. And then we try x is equal to a number to the right of 5. Yeah, 6 is a good choice. So we do 6 multiplied by 6 minus, 3 minus 6, 3 minus 6, and then multiply by 6 minus 5. And we see that's positive 6 times negative 3 times positive 1. That gives us a negative number, negative 18. And so we get a negative here. And then since this inequality says we want the regions less than 0, we want the negative regions. And since that's less than or equal to, we use brackets. So I'm going to shade all the negative regions, shade all the negative regions. And this one on the right-hand side keeps going on forever. And I'll put a bracket at each border of the shaded region that opens in the direction that we shade. And so if I were to graph the solution then, if I were to graph the solution, my graph will basically look like this. And basically all I'm going to do is redraw the graph with all the pluses and minuses. So 0 to 3 and 5 to infinity. So I'll shade from 0 to 3 and from 5 to infinity. So my solution would be start at 0 with a bracket, comma, stop at 3, bracket, or start at 5, comma, go to infinity. Any number in those regions would be a solution. Let's try 3 more. Now these are special ones which I've chosen. These involve some work. This one looks a little tedious, but it's not quite. We're going to solve the equation, the corresponding equation, and we can actually solve this one by factoring, by grouping. We can group each pair. And remember, we're solving the corresponding equation to find the markers to plot on the number line. So I factor out x squared from this first pair, and I get x plus 2. And I factor out negative 4 from the second pair, and I get x plus 2. So things are looking bright for us so far. And then I factor out x plus 2, and I have x squared minus 4. And that factors as well to give us x plus 2 times x minus 2. So if I solve this number, I get x plus 2 equal to 0 twice. So I'm just going to write that once and have x minus 2 equal to 0. So those are my two markers. It turns out I only got two markers because one of them was a repeated solution, a repeated root, or a repeated 0. So what I'm going to do now is I'm just going to plot those on my number line. And because of the space, I'm not going to be able to show the working for the spaces, but we have the idea right now. So I'm going to choose a number to the left of 2 and a number to the right of 2. A number to the left of 2, for example, would be negative 3. So we'll do negative 3, the cube of negative 3. And of course, you can use your calculator for this. The cube of negative 3 plus 2 multiplied by negative 3 squared, then minus 4 multiplied by negative 3, and then minus 8. And let's see, we get a negative 5 for that, and so the solution for that region would be a negative. Then we try a number in between, negative 2 and 2. Of course, the most obvious number to try is 0. 0 cubed plus 2 times 0 plus minus 4 times 0 minus 8, of course, gives you negative 8. So that's also a negative solution. And then on the next number we're trying on the right side of 2 would be 3. And so if we go and try 3 now, 3 cubed plus 2 times 3 squared minus 4 times 3, and then minus 8. And we see we get a positive number here, a positive 25. So we end up with a positive here. And according to this inequality, we only want the positive values and greater than or equal to. So I'm going to use my number line, shade to the right, and use a bracket. So my actual graph of my solution, will be starting only at 2 and shading to the right at 2 with a bracket at 2. And again, I'm going to leave you to check the solution to make sure it works. So the solution is bracket 2, comma, positive infinity, parentheses. Now, with this one, we have to again rewrite the inequality in standard form. So it's x cubed minus 1 is greater than 0. And now we solve the corresponding equation, x cubed minus 1 equal to 0, which is a difference of cubes. So it's x minus 1 times x squared plus 1x plus 1. And then we solve each part. X minus 1 equal to 0, or x squared plus x plus 1 equal to 0. This one cannot be factored, so we're going to solve it using the quadratic formula. So the quadratic formula is negative b, so it's negative 1 plus or minus the square root of b squared, 1 squared, minus 4 times a times c times 4 times 1 over 2 times a. And with what we realize here, when we try to solve it that way, we get a pair of complex number solutions because we have the square root of a negative, square root of negative 3. So this is not a real number, and when we're solving inequalities, we need real numbers because we're plotting them on the real number lines. So the only solution we actually got wasn't from this equation. The only marker we ended up with was 1. So we're only putting 1 marker on the number line. And then we're going to check to see what number works. So when I put 1 on the number line, I choose a number to the left of 1, namely 0. I plug in 0, I get negative 1. So we have a negative on the left of 1. And then when I choose a number to the right of 1, say 2, I plug in 2, I get 8 minus 1, which is positive. So we get a positive on the right of 1. And so then my graph then, since I want values that are greater than 0, my graph would be starting from 1, I shade to the right, and since I only have a greater than sign, not a greater than or equal to sign, I use parentheses. So that would be the graph. And then the solution in interval notation would be open parentheses 1, comma, infinity. That means when x is greater than 1, this statement is true, but when x is to the left of 1, this statement is not true. Let's try this example here. Let's try this example. We have 4x squared plus 1 greater than or equal to 4x. Of course, that's not in standard form, so we set everything on one side and greater than or equal to 0. And then I solve the corresponding equation, 4x squared minus 4x plus 1 equal to 0. And I can solve that one by factoring. You can check the work for that one. That is 2x minus 1 times itself. And that would lead us to meaning that 2x minus 1 is equal to 0. So x is equal to half. There's only one marker. So I'm going to do my little number line thingy and put the number half. So tell me a number to the left of half. Clearly, easiest number to choose is 0. I plug 0 in here. I get 4 times 0 minus 4 times 0 plus 1 is 1. That's a positive number. So I'm going to get a positive answer on the left-hand side. Now I try a number to the right of half, namely 1. Plug in 1. 4 times 1 is 4. Minus 4 is 0. Plus 1, still 1. Positive. Got a positive here. So this means everything will work to the left of half and to the right of half. But does half work? And the answer is yes. Half works because we're including it. So that we put a bracket actually facing both directions, which basically means whatever we plug in works. So for this answer, the whole number line is a solution. The solution is actually all real numbers. Everything works. So the solution then is negative infinity to positive infinity. Now let's go on to another example. Another example here is 3x squared plus 4x plus 3 is greater than 0. It's already in the form that we want, so we try to solve it. We solve the corresponding equation. 3x squared plus 4x plus 3 equal to 0, and this is to get markers. Now, to get markers here, we cannot factor this, so we try this quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4 times a times c, and that divided by 2 times a. So that gives me x is equal to negative 4 plus or minus 4 squared is 16, and 4 times 9 is 36. So we have 16 minus 36, negative 20. Again, we have complex solutions. These are not real numbers. No real numbers, not real numbers. So we have no solution. So there are no markers, which means whatever numbers we use will either always work, they will always be positive or always be negative. So let's try a number, any number. So if we try x equal to 0, because that's the easiest number, we get 3 times 0 squared plus 4 times 0 plus 3 is equal to 3, which is positive. And that means whatever number I plug in, I will get a positive answer. Try it. In fact, if I try a negative number, I try negative 2. 3 times the square of negative 2 is 4. 3 times 4 is 12. 4 times negative 2 is 8. 12 minus 8 is positive. 4 plus 3 is still going to give us a positive number. I can try 1,000 and it will still work out to be a positive number. No matter what number I choose, we'll always get a positive number. So then the inequality is, the expression is always positive. So 3x squared plus 4x plus 3 is always greater than 0. It's always positive. So then our solution, our graph would simply be the whole number line again, the whole number line. So the solution would be, since it's a whole number line, my solution would be negative infinity to infinity. All real numbers will work for that inequality. Let's try this one here. We have 2x squared plus 2 minus, so we can rearrange that and we end up with 2x squared minus 3x plus 2, and that would be greater than, oh sorry, less than 0. If we try to factor that, we may get stuck. So let's try the quadratic formula. So we have 2x squared minus 3x plus 2 is equal to 0. X is equal to negative b, which is negative of negative 3, plus or minus the square root of 3b squared, which is square of negative 3, minus 4 times a times c. All right, so divide by 2 times a. So what do we get when we do that? We get x is equal to 3 plus or minus the square root of 9 minus 16. That's negative 7. And that's over 4. Again, this is no solution, no real number solution. So these are not real numbers, and we need real numbers for this inequality. So once again, we're saying that the expression has no markers because we got no solution. So the statement is either always positive or always negative. So I try a number. So let's say we try again 0, x equal to 0. It's an easy number to try. 2 times 0 squared minus 3 times 0 plus 2 is equal to 0. Oh, sorry, is equal to 2. which is a positive number. So we're saying that 2x squared minus 3x plus 2 is never less than 0, which means 2x squared minus 3x plus 2 less than 0 is never true. Not for real numbers, which leaves us then with the fact that nothing works, so there is no solution. The graph has nothing on it. We usually use a circle with a slash, and this graph is just an empty line with no answers on it, no points plotted, no solution. Let's do our last example with this part of the concept, which is 9x squared less than or equal to 6x minus 1. As before, we put it in standard form, and then I solve the corresponding equation. 9x squared minus 6x plus 1 is equal to 0. I can solve this. I am to be able to solve this one by factoring. 3x minus 1 squared is equal to 0, which means x would equal to 1/3. So I end up with a marker. So now I draw my number line, and I put my marker 1/3. And I try a number to the left of 1/3, say 0. I plug in 0, I get 9 times 0 minus 6 times 0 plus 1. That's going to give me a positive answer. And I try a number to the left of 0, to the right of 0, namely 1. 1 is a good number to try. We try 1, and we do 9 times 1 minus 6 times 1 is 9 minus 6 is positive. 3 plus 1 is positive again. And so the inequality says numbers that are less than or equal to 0. Nothing here is less than 0. And the only number that works is right there. Just that 1 point. 1/3 is the only number that gives us an answer. When we plug in 1/3, we get 0. 9 times 1/3 squared is 9 times 1/9 is 1. And then negative 6 times 1/3 is -2. So 1 minus 2 plus 1 is 0. So then with our solution then is simply the number 1/3. That is it. No other number, just the 1 point on the graph. So the graph is actually just a point. That's all. Now we're going to do some other types of inequalities now. The last one on this topic is rational inequalities. Rational inequalities. And the question is, how do we solve rational inequalities? Now I want to point out here, whenever you're solving a rational inequality, never cross multiply over an inequality. Because if you're cross multiplying by a number that's negative, the inequality is supposed to be reversed. But if you're cross multiplying by a number that's positive, your inequality is gonna stay the same. So if you don't know what you're cross multiplying by, and when I say never cross multiply, I mean never cross multiply with a variable. If you don't know if your variable is positive or negative, you don't know if you should keep the inequality or not. So do not cross multiply. So how do you go about it? The first thing you do is you get the inequality, the fractions to one side. So you get 0 on one side of the inequality. So with my example here, we're gonna subtract x plus 1 over x minus 1 from both sides. And then that will complete step 1. Step 2, combine the fractions into one fraction. So I'm going to multiply the numerator and denominator by an appropriate number to get a common denominator. I multiply numerator and denominator here by x minus 1, and numerator and denominator here by x plus 2. And when I combine the fractions, I can distribute the parentheses, but because it's a minus, I'm going to keep that minus, and when I distribute this parentheses, I keep that in parentheses. So my solution then continues on the next slide. When I combine those two, the numerator, I get negative 7x plus 1, and the denominator I will leave without distributing, because it's going to be easier to solve. Now that I have a combined fraction, I factor whatever can be factored, which is already factored here, and then I solve the corresponding equation. I solve the corresponding equation. Well, I solve the equation for the numerator, and I solve the equation for the denominator. Now, a little side note here. If you have a less than or equal to, your numerator will get a bracket. But if you only have a less than or a greater than, your numerator will get a parenthesis. Now, that's explained over here. If the inequalities are less than or equal to or greater than or equal to, the numerator marker will be a bracket. But if the inequality is a less than or greater than, that means a strict inequality, your marker will be parentheses. Denominator markers are always parentheses because the denominator is never allowed to be 0. So we set our denominator equal to 0 and we solve, and both of those get parentheses. So the denominator only gets parentheses and the numerator markers get brackets. Let's continue. Now I'm going to plot my markers. I've already plotted them here in order: -2, 1 over 7, and 1. And so I'm going to remember that the markers have a bracket at 1/7 and a parentheses at -1 and 1. And then I'm going to find my numbers just like I did with polynomial inequalities. In this case, I'm going to try -3, a number to the left of -2, in the inequality combined. And when I plug those in, I get 22 over 4, which is a positive number. So then I'll put a positive marker. Then I'm going to go to my next inequality, my next region, which is between -2 and 1/7. I choose a number between, say, 0. And I plug it into my inequality and I get -½ So that means any number in the region there will give me a negative number. Then I'm going to go to my next region. My next region is between 1/7 and 1, which is half is a good number to try. It's bigger than 1/7 but smaller than 1. I plug it into the inequality and I get a +2. So that region gives me a positive. And then finally a number to the right of 1. I can try, say, 2. I plug in 2 and I get -13 over 4, which is a negative number. So that region is a negative. So then I have all my regions marked. Now I need to figure out whether what region I should use. Now this says the fractional rational inequality is less than or equal to 0. So I'm going to shade the regions that correspond to the negative. So I'm going to shade the region between -2 and 1/7 and greater than 1 to the right of 1. So I'm going to shade. And remember, I'm going to put parentheses at 2 and 1, and I'm going to put a bracket at 1/7. So I'm shading between 2 and 1/7, and I'm shading after 1. And I'm going to put a parenthesis at -2, opening in the direction that I shaded, a bracket at 1/7, opening to the direction that I shaded, and parenthesis at 1, opening in the direction that I shaded, opening to the right in this case. And now I can do my interval notation, namely parentheses -2, comma 1/7. Start at -2 with a parentheses, end at 1/7, union, or start at 1, go on to infinity. And now we can do a few examples. So my examples. This first one here is already in the format that I want, so all I need to do is get my markers. So the first marker I'm going for is the numerator. So for the markers, we have to do the markers for the numerator and the markers for the denominator. For the numerator, my markers are going to be -4 and +1. Because I set the numerator equal to 0, I solve each part, I get -4 and I get +1. And since that there's a greater than or equal to sign, then I know that my markers will be using brackets. And then for my denominator, and denominator markers always use parentheses because the denominator is not allowed to be 0. My denominator is just x plus 2. So I set that equal to 0, I get x is equal to negative 2. And so my marker there for the denominator is negative 2. And that will always be parentheses. And then I do my number line, and I mark my markers in order: negative 4, then negative 2, then positive 1. And then I'll choose numbers between them. And I'm not sure if I have enough space here, but let's try a few numbers here. So we try, to the left of negative 4, we use x equal to, say, negative 5. And we plug that into the whole fraction. So we have negative 5 plus 4 times negative 5 minus 1 over negative 5 plus 2. And so we have negative 1 times negative 6 is positive 6 over negative 3. And that gives you a negative number, a negative 2. So our inequality here on the left side gives us a negative. And then in between negative 4 and negative 2, I can try negative 3. And it seems I won't have the space here, so I'm just going to check it out. And negative 3 gives us negative 3 plus 4 is positive 1. Negative 3 minus 1 is negative 4. Negative 3 plus 2 is negative 1. So we have a positive, a negative on top, and a negative at the bottom. We are going to get a positive answer. And so that region is going to have a positive. And then a number between negative 2 and 1 would be 0. And so I'm going to put an and so on here. And we're going to have plug in 0, get positive 4 times negative 1 is negative 4 divided by 2 is negative 2. So when we try 0, we get a negative. And then we try a number that's to the right of 1. Plug in 2, for example. 2 plus 4 is 6. 2 minus 1 is 1. 2 plus 2 is 4. So we get a 6 times 1 over 4. That's a positive number, a positive 3/2. So now we have all our regions. Since this says less than or equal to 0, we're going to shade the regions that are negative to the left of negative 4, between negative 2 and 1. Negative 4 has a bracket, so we'll put a bracket there. And negative 2 has parentheses, so we'll put parentheses there. And then 1 has brackets, so we'll put bracket there. So my number line has my answers there. So the solution then from the number line, is negative infinity to negative 4 bracket union, or negative 2 to 1 bracket, and that's my solution. Continuing with the next example. Again, we do not cross multiply when you have an inequality. What you do is you get everything equal to 0. And then combine the fractions. So we have x minus 2 times the quantity x plus 2, all of that over x plus 2. We're just combining them into one fraction. And then that means x minus 2x is negative x, and negative 2 minus 2 is times negative 2 is negative, times positive 2 is negative 4. And then I have to get my markers. So let's go for our markers here. So for our markers, the numerator marker would be negative x minus 4 equal to 0, which would mean x would be equal to negative 4. And again, that marker is a bracket because it's a greater than or equal to. And then for the denominator, we have x plus 2 equal to 0, which would mean x is equal to negative 2. And then that is going to be parentheses. And so I draw my number line, I put my two markers, and I check my values. My first marker on the left is -4, and on the right is -2. A number to the left of -4 would be -5, and I plug in -5. I get -5, -5 is 5, 5 minus 4 is 1, -5 plus 2 is -3, so positive over a negative is a negative. So this is a negative region right here. Negative region right here. Between -4 and -2 would be -3. So I do -3 is 3, 3 minus 4 is -1, -3 plus 2 is -1. Negative divided by negative is a positive. So that's a positive region right there. And then to the right of -2, we can try 0. 0 minus 4 is -4. 0 plus 2 is +2. -4 over +2 is a negative number. And since this inequality is asking for greater than, we're looking at only the positive region. So I'm only shading the region between the two. We'll use a bracket at 4 because that's from the numerator marker. And it's a greater than or equal to. And the denominator marker is -2. That's parentheses. So my solution here is bracket -4, comma, -2, parentheses. Let's move on to the next example. More complicated, but we can do it. We never cross multiply. Never, ever cross multiply by a variable when you have an inequality. So this one might take up some space. So we're going to see if we can fit it all in the region that I have here. And now we combine the fractions. So we're going to do multiply top and bottom here by x plus 1 and top and bottom here by x minus 3. And then the denominator we will not distribute. We'll just leave it as x minus 3 times x plus 1. And then we simplify the numerator. 5x plus 5 minus 3x plus 9. And we're not going to distribute the denominator because we're going to need those markers. And so we end up with 5x minus 3x is 2x. 2x plus 14 over x minus 3 times x plus 1. And that's greater than 0. Now, I am going to need a little space here. So what I'm going to do is I'm going to just continue the work on the left side here. Well, we may be able to fit it in. So for our markers, for my numerator markers, I have 2x plus 14 equal to 0. So x is equal to -7. And for my denominator markers, I have x minus 3 times x plus 1 equal to 0. So, pardon me, let me just fix this. X is equal to 3 or x is equal to -1. Now, everything, all the markers here are parentheses because there's no equals bars. It's just strictly parentheses. So for the next step, we're just gonna graph our inequalities. I'm gonna graph my little number line here. And I'm gonna kind of squeeze it in. I apologize for the spacing issues, but it's a bit of a challenge here. So I beg your pardon, but let's keep going here. So the numbers in questions are -7, which is on the far left. -7 on the far left. -1 is the next number line, and +3. So I try a number to the left of -7, say 10, -10. 2 times -10 is a -20 plus 14. That's a negative number. -10 minus 3 is -20. negative 13, and that's a negative number, and then negative 10 plus 1 is negative 9. So you have negative divided by the product of two negatives. That's the negative divided by a positive, and that gives you a negative. So there's a negative on the left side. And then between negative 7 and negative 1, we can try negative 5. 2 times negative 5 is negative 10 plus 14, that's a positive 4. Negative 5 minus 3 is negative 8, and negative 5 plus 1 is negative 4. Positive divided by negative times negative is positive divided by positive, and that happens to be positive. A number between negative 1 and 3 is, of course, 0. Plug in 0, get positive 14. Plug in 0 here, get negative 3 times positive 1. Positive divided by negative is negative. And finally, a number to the right of 3, say 4. 8 plus 14 is a positive number. 4 minus 3 is positive. 4 plus 1 is positive. Positives all around, so we're going to get a positive result. So then, according to this, we're going to use the numbers that are in the positive region. So we're going to use between that and to the right of 3. And all of them have parentheses. So my solution here is negative 7 to negative 1, along with 3 to infinity. And I'm going to leave you to check those. And we have just one more set of examples to do. Similar example here. We do 1 over x minus 2 is minus 2 over 3x minus 9 is less than 0. And then we combine fractions, we get 3x minus 9 minus 2 times x minus 2 over x minus 2 times 3x minus 9 is less than 0. Solving this, we get 3x minus 2x is x, negative 9 plus 4 is negative 5, and we end up on the denominator, we have x minus 2 times 3x minus 9. So we're less than 0. So my numerator marker is x minus 5, which gives me 5. And my denominator markers are x minus 2 times 3x minus 9. And those give me 2 and 3. 2 for the first one and 3 for the second one. Now, using my markers, I'm going to put them on the number line here. And now let's mark them on the number line and see what we got. The furthermost one is 2 to the left, and then 3, and then 5. Number to the left of 2 that we can try is 0. We get a negative on top, and a negative times a negative at the bottom. So we have a negative overall. A number to the right of between 2 and 3 would be 2.5. 2.5 minus 5 is negative. 2.5 minus 2 is positive. 3 times 2.5 is 7.5. And so when we subtract 9 from that, we get a negative. So we have negative on top, positive times negative. We have a negative divided by a negative. We end up with a positive result. A number between 3 and 5 would be 4. 4 minus 5 is 1, negative 1. 4 minus 2 is positive. And 3 times 4 is 12 minus 9 is a positive. Negative divided by a positive is negative. And number to the right of 5 is 6. 6 minus 5 is 1. 6 minus 2 is positive. 3 times 6 is 18 minus 9 is positive. Positive divided by positive is positive. And according to this, we want the negative guys, so we're going to shade to the left and shade in between. And we put parentheses because all the markers are, these are strict inequality. So all the markers have parentheses. So my solution then is negative infinity to 2 union 3 to 5. Continuing, this one is already in the form that we want, so we can just get our markers together. For our numerator markers, we're talking about x minus 2 squared equal to 0, which means x is equal to 2, and that marker will be a bracket. And the reason is that's a greater than or equal to. And then we have for our denominator, we have x squared minus 1 equal to 0, which, if you remember from your quadratic equation, that's positive or negative 1. So we have 2 markers from that one. And so we end up with the number line having 3 markers. 3 markers. The markers here are negative 1, then 1, then 2. Plugging a number to the left of negative 1, say negative 2. Negative 2 minus 2 is negative 4 squared is positive. Negative 2 squared is positive, minus 1 is still positive. So this gives us a positive on the left. A number between negative 1 and 1 is 0. We get 0 minus 2 squared is positive. 0 minus 1 is negative, so we get a negative. A number to the right of 1 is, say, 1.5. 1.5 minus 2 squared is positive. When you square it, you get a positive. And 1.5 squared is a bigger number than 1. So that's what will give you a positive result. So it's a positive divided by a positive here. Number to the right of 2 is, say, hold on, let me see if I made an error here. 1.5 minus 2 is, wow, 1.5 minus 2 is, oh, this was supposed to be a negative right there. Pardon me. So I plug in a number between 1 and negative 1. If I plug in 0, I'm supposed to get a negative. That's where the negative is supposed to be. Apologize for that. I just lost my train of thought. Now, when I plug in a number to the right of 1, from 1 to 2, 1.5, I get a negative squared on top is a positive, and a negative squared at the bottom. 1.5 squared at the bottom minus 1 is positive. And a number to the right of 2, like 3, will give me a positive over a positive. So this thing works for numbers to the left of 1, because those are positives, between 1 and 2, and to the right of 2. And since we use a bracket at 2, the bracket will go both directions, and we use a parenthesis at 1 and negative 1, then my graph really should look something like this. So because it includes all the values to the right. So my solution then is negative infinity to negative 1, parentheses, or 1 to infinity, also with parentheses. Now for our last example, the markers again. The numerator markers are going to be x times x squared plus 1 times x minus 2 equal to 0. And when I solve these, I get the markers are going to be x equal to 0, but x squared does not give you a negative 1. So that gives me no markers right there. And then x minus 2 is going to give me 2. So I have 2 markers there, both of them with brackets because of the less than or equal to inequality. And then for my denominator markers, For my denominator markers, I have the two numbers 1 and -1. So my markers are 1, -1. So again, I go to my number line, and let's see how many markers I have to put here. The marker to the left is -1, then the next marker is 0, then the next marker is 1, then the next marker is 2. So I have to try all of those numbers. I try a number to the left of -1, say -2, I get -2. This number will be positive, and that will be negative. Negative times positive times negative is positive. -2 minus 1 is -3, and -2 plus 1 is negative. So we have negative times positive and negative, positive on top, positive at the bottom. So we have a positive for this region. Try a number between -1 and 0, like -0.5. A -0.5 here. This is going to be positive, and negative here as well. So there's a positive on the numerator. This is negative, and that's positive. Positive divided by negative is negative. Try 0.5. Positive here, negative here. So it's a negative numerator, and negative here, positive here, negative denominator. Negative divided by negative is positive. Between 1 and 2, 1.5. That's a positive number. That's positive, and that's 1.5 minus 2 is negative. That's a positive number, and that's positive. So we have positive times negative over positive. That gives us a negative. And finally, a number to the right of 2 is 3. Positive, positive, 3 minus 2 is positive, 3 minus 1 is positive. So all of them are positive. So we are looking at all the regions where we have positive answers, and we're going to only shade those. So we're going to shade to the left of -1, positive because it's greater than or equal to 0, between 0 and 1, and after 2. And the bracket goes with 2, so we'll put a bracket there. And as bracket goes with 0, so we'll put a bracket there. And we have a parenthesis with 1 and -1. So then my solution is parentheses -infinity to -1, parentheses union, bracket 0 to 1, with a parentheses at 1 and a bracket at 0, union, bracket 2 to infinity. Now, we've done quite a few examples here. There is quite a lot to do, so I'm going to ask you to try a number of these questions, and of course, please do Khan Academy and try those questions. Go through step by step and make sure you understand each step carefully, and you only get good at this stuff by practice. That's all for now, and make sure you're going through carefully step by step. All the best.